Hi, this is the third video on the Level 3 Algebra Essential Skills. This is from the set of worksheets that's labelled Essential Skills 3. A quick reminder that these worksheets are designed to give you the best possible chance of being successful in your Level 3 Algebra exam. Although I don't cover every single skill that you need in Level 3 Algebra, there's enough here so that you can feel confident when you walk into that exam. I'd recommend you download the worksheet so that you can have a go at the questions before you follow this video, or alternatively you can follow along with me, just pause the video so that you can have a go at the questions first. Having said that, we'll get started. So question number 1, we want to factorise the expression x squared take away 4x take away 12. I'm looking for two numbers that multiply together to give me the negative 12 but add together to give me the negative 4. So the two numbers I've identified is negative 6 and 2. So I'm going to write this as x take away 6 times x plus 2. Okay, question number 2. We want to make x the subject of this formula here. So I've got y is equal to 6x over x plus 3. Okay, the first thing I'm going to do is I'm going to multiply both sides by x plus 3. So I'll write it over here, we're going to have y times x plus 3 is equal to 6x. I now would want to expand the brackets because I want all of my x terms to be on one side. So let's do that first. So that's going to give me xy plus 3y is equal to 6x. And now I'm going to subtract xy from both sides so that I can bring all my x terms on one side. So that's going to be 3y is equal to 6x take away xy. Okay, running out of space there. Let me just draw a line over here. Okay, so my next step here is I'm going to factorise this. So that's going to give me 3y is equal to x and 6 take away y. Okay, I factorised it, so now the x is only mentioned once, so I can isolate it. I'm now going to divide both sides by 6 take away y. So that gives me 3y over 6 take away y is equal to x. Okay, and I've now made x the subject of the formula. I would usually write it the other way around, but that will do for now, so we'll leave that there. Okay, question number 3, we're simplifying 7 root 2 squared. So remember, that means 7 root 2 times 7 root 2. So I'm going to do the 7 times 7 bit, which is 49. And the root 2 times root 2 is just going to give me 2. So I've got 49 times 2, which gives me 98. Okay, part B, we're asking to simplify this over here. Now, what I want to do is I want to see if I can simplify each of them individually first. So the root 20, I know that can be written as root 4 times root 5. So root 20 is going to be the same as 2 root 5. Okay, because root 4 is 2. Plus root 45 can be written as root 9 times root 5. And I know that root 9 is 3. So I'm going to write this one as 3 root 5. Okay, and now you can see that I've got a common surd here of root 5, so I can actually add these together because 2 lots of root 5 plus 3 lots of root 5 is going to give me 5 lots of root 5. Okay, so that is that simplified. Okay, question number 4, we're still sticking with surds. This time we want to expand these brackets out over here. Okay, so what I'm going to do first though here is I'm going to see whether each of these simplify first of all. So that root 32, I can see that 32, the largest square factor of 32 is 16, so I could actually write this as root 16 times root 2. And root 16 is 4, so I'm going to rewrite this part here as 4 root 2. And I've still got this take away root 2, and I'll put my brackets in. Okay, so those two are the same as each other. Okay, similarly for root 12, I can see that root 12 is going to be root 4 times root 3, and root 4 is 2, so that's going to be 2 root 3. Okay, so I've got 2 root 3 take away root 3. Okay, so 4 root 2 take away root 2 gives me 3 root 2. and 2 root 3, take away root 3, gives me 1 root 3. So this time, rather than expanding it out, I've seen that I can actually simplify what was in the brackets initially. And now these two can just multiply together, because 3 root 2 times root 3, well, that's just going to be 3 times root 2 times root 3, and root 2 times root 3 I know is going to give me root 6. So my answer here is going to be 3 root 6. So it may have been tempted to start with to just expand all the brackets out, but because I saw that these numbers were quite large, I decided to simplify them first. And as you can see, that has made it a lot simpler, and we'll be able to just get to our answer easily as 3 root 6. Okay, question number 5, we're rationalizing the denominator of this expression here. So as always, we want to multiply the numerator and the denominator by the conjugate of the denominator. So I'm going to multiply this by 4 plus root 5 and 4 plus root 5 there. Okay, so just to make it clear as to what's going on here, I'm going to write this in double brackets. So I've got 8 take away root 5 multiplied by 4 plus root 5, and then we're going to have 4 take away root 5 multiplied by 4 plus root 5. Oops, I missed a bracket there. Okay, so let's do the numerator first over here. So that's going to give me, I've got 8 times 4, which is 32. I've got 8 times root 5, so we've got plus 8 root 5. We've got negative root 5 times 4, so we're going to take away 4 root 5. And then root 5 times root 5 is 5, but it's going to be take away because there's a positive and a negative. That's going to be take away 5. Okay, and the denominator, I've got 4 times root 5. Sorry, I've got 4 times 4, which is 16. Let's try that again. 4 times 4, which is 16. 4 times root 5, which is plus 4 root 5. Negative root 5 times 4, so that's going to be take away 4 root 5. And then we've got root 5 times root 5, so it's going to be take away 5 again on the denominator. Okay, right, so got a little bit messy over here. I'll come down here. So we've got, on the numerator, I've got 32, and I've got that take away 5, so that's going to give me 27. I've got 8 root 5, take away 4 root 5, which is plus 4 root 5. And then on the denominator, I've got 16 take away 5, which is 11. And then you'll see that these two here will cancel each other out. Okay, so I'm going to have 27 plus 4 root 5 over 11. Okay, on question 6, we want to simplify this expression over here. So I've got x to the power of negative a third and to the power of 6. So what I'm doing here is I'm multiplying the two powers together. So that's going to be equal to, and that negative third to the power of 6, we're going to multiply them together, so a negative third of a 6 is going to be negative 2. So we're going to have x to the power of negative 2. On question 7, this time I've got 27 lots of p to the power of negative 6 to the power of a third. Okay, so I need to do both of these to the power of a third. I need to do the 27 to the power of a third and that p to the power of negative 6 to the power of a third. So 27 to the power of a third, remember that just means a cube root. So I'm going to do the cube root of 27, which is 3, because 3 times 3 times 3 is 27. Okay, that's that part done. And then p to the power of negative 6 to the power of a third, I'm just again doing a third of a negative 6. So that's going to be negative 2. So I've got 3, whoops, let's try that again. Okay, so that's going to be 3p to the power of negative 2. I forgot to write the p down. Okay, 3p to the power of negative 2. Okay, question 8. We want to use the quadratic formula to solve this equation here. So my first job is to write down the quadratic formula. So I know that's going to be x is equal to negative b plus or minus the square root of b squared take away 4ac all over 2a. Okay, so I'm going to write down what the values of a, b and c are. So I know that a is going to be equal to 2, b is going to be equal to 3, c is going to be equal to negative 11. And the other thing I'm going to write down is what the value of the discriminant is, which is b squared take away 4ac. So b squared take away 4ac is going to be equal to 3 squared, which is 9, take away 4, times 2, times negative 11. Okay, so that's going to be 9, take away 4 times 2 is 8, and 8 times 11 is 88. And we can see this is going to be a plus now, so it's going to be plus 88, and that gives me 97. Okay, so now I've got all of those values here. I can just put it into the quadratic formula. That tells me x is going to be equal to negative b, which is negative 3, plus or minus the square root of b squared minus 4ac, which I worked out to be 97, all over 2a, that's going to be 2 times 2, which is 4. I've got negative 3 plus or minus square root of 97 over 4. Okay, question 9 says, find the value of p such that px squared plus 8x take away 4 equals 0 has 2 equal roots. So I want 2 equal roots, so sometimes we say that it has one root or a repeated root, but what we're going to say for this, in order for it to have 2 equal roots, the discriminant would need to be equal to 0. So I'm going to say b squared take away 4ac must be equal to 0. Okay, so I'm going to write down what my values of a, b and c are. I'll do that over here. So a is going to be equal to p, b is going to be equal to 8, and c is going to be equal to negative 4. Okay, I'll substitute these into here now. So b squared, that's going to be 8 squared, which is 64. Take away 4 times a, which is p, times c, which is negative 4, must be equal to 0. So that tells me that 64, and then we've got a negative and a negative, so it's going to be plus 4 times 4 is 16, and we've got 16 times p, so it's going to be 16p is equal to 0. So that tells me that 16p is going to be equal to negative 64. So I'll subtract the 64 from both sides, and then finally I'm going to divide both sides by 16. So p is going to be equal to negative 64 divided by 16, which is negative 4. Okay, so in order for this to have 2 equal roots, the value of p, or this number here, would have to be negative 4. Okay, question 10. Find the sum and the product of the root of the equation 3x squared take away 9x plus 3 is equal to 0. Okay, so I'm going to remind myself that the sum is going to be equal to negative b over a, and the product is going to be equal to c over a. So I'll start by writing down what a, b and c are. So a is going to be equal to 3, b is going to be equal to 9, and c is going to be equal to 3. Okay, so negative b over a is going to be negative of negative 9, which is 9 over 3. And we can see that's just going to be equal to 9 divided by 3, which is 3. And then c over a, well, that's going to be 3 divided by 3. And we can see that 3 divided by 3 is equal to 1. So the sum of the roots is going to be 3, and the product of the roots is going to be 1. Question 11. Find the quadratic equation with integer coefficients where the sum of the roots is 2/5 and the product of the roots is negative 3/5. Okay, so if the sum of the roots is going to be 2/5, that means that negative b over a is going to be equal to 2/5. And if the product of the roots is going to be negative 3/5, then that tells me that c over a must be equal to negative 3/5. Okay, so I'm going to write down what the values of a, b and c could be. So a is equal to, b is equal to, and c is equal to. Okay, because I can see a common denominator here, okay, so it makes sense for me to choose a to be 5. So I'm going to say that a is equal to 5. And because b here is, so because I've got a 2 here, that tells me that negative b must be equal to 2, in which case b is going to be equal to negative 2. And because I can see I've got a negative 3 here, so that c must be equal to negative 3. Okay, so I now know what the coefficients are going to be. I need to now write down the quadratic equations, which is going to be ax squared plus bx plus c equals 0, so it's going to be 5x squared, take away 2x, take away 3 is equal to 0. So that equation, the sum of the roots would be 2/5, and the product of the roots would be negative 3/5. Question 12. P is directly proportional to q squared. And we're told when p is equal to 40, q is equal to 2. And we want to write down a formula for p in terms of q. So because it's directly proportional, the first thing I'm going to write down is that p is going to be equal to k times q squared. Okay, I'm now going to use the information I've been given to work out what k is. So when p is equal to 40, I'm going to replace the p with 40, and q is going to be 2, so we're going to have k times 2 squared, so 2 squared is 4, so that's going to be 4k, and that tells me that k is going to be equal to 40 divided by 4, which is 10. Okay, now that I know that k is 10, I can write down this equation here. Instead of the k, I'm going to write 10, so I've got p is equal to 10q squared. Okay, question 13. What is the nth term of this sequence over here? I can see that it's going up by 3 each time, so I'm going to start by writing down 3n. And then the first number in my 3 times table is 3. I can see that this is negative 4, so it's 7 less than my 3 times table, so it's going to be 3n take away 7. Question 14, we want to find the sum of the first 100 terms of this arithmetic series here. I'm going to start by writing down the information that I know. I know the first term is going to be 9, so I'm going to say that a is equal to 9. I know the common difference is going up by 6 each time, so I'm going to say that d is equal to 6. And I know that there's 100 terms, so the number of terms is going to be equal to 100. So the formula I'm going to use here is the sum of the terms is going to be a half of n, and then into square brackets I'm going to have 2a plus n minus 1 times d. So let's put the values in. So the sum of my first 100 terms is going to be equal to a half of n, so that's going to be half of 100, which is 50, times, and then we've got 2a, so that's going to be 18, plus n minus 1, so that's going to be 99 times 6, which is my common difference. Okay, so if I come over here, I'm now going to have the sum of the 100 terms is equal to, still got my 50 over here. I'm going to work out this bit first, so that's going to be 18 plus, and 99 times 6, well 100 times 6 is 600, so 99 times 6 is going to be 6 less than that, which is 594. Okay, so that's going to be 50 times, and 18 add 594 is 612. So now I'm going to do 50 times 612, and obviously do this in whichever way you feel comfortable. So I'm going to multiply it by 100 and then half it, and that's the same as multiplying by 50. So multiplying by 100 gives me 612,000, sorry, and then if I half that, so it gives me 61,200, and if I half that, that gives me 30,600. Okay, so my answer for that one is 30,600. Okay, question 15, we're finding the equation of the line that passes through these 2 points over here. Okay, so I first need to know what the gradient is, and then I can work out the y-intercept, so I can write it in the form y equals mx plus c. So I'll start by working out the gradient. So if I write them on top of each other, we've got 1, 4, and we've got a -3 and -8. Okay, remember my gradient is going to be the change in y divided by the change in x. Okay, so let's see what's happening here. The change in y, well I can see that it's gone from a 4 to a -8, so the change in y is -12, and the change in x, I can see it's gone from a 1 to a negative 3, so it's gone down by 4, so the change in x is going to be negative 4. So we've got negative 12 over negative 4, and that's the same as 12 over 4, which is just 3. Okay, so I now know that my gradient is 3. So I'm going to write this down over here. That tells me that I know that my equation is going to be y is equal to 3x plus c. And I know I'm going to use this point over here. So when x is 1, y is equal to 4. So I'm going to use that information in here. So I'm going to replace that with a 4. So I've got 4 is equal to 3 times 1, which is 3, plus c. And that tells me that c is going to be equal to 1. So my equation is going to be equal to y is equal to 3x plus 1. Okay, and I'm just going to check it in this set of coordinates over here. So essentially that's telling me to work out this one, I need to times this by 3 and add 1. So 3 times negative 3 is negative 9, add 1 gives me negative 8, and I can see that it works. Okay, question 16, I've got 4x squared, take away 7x, take away 15. I'm looking to factorise it because I've got a coefficient here of the x squared of 4. I know that I'm going to use my AC method, so I'm first of all going to write down that AC is equal to 4 times negative 15, which is negative 60. And I also know that B is equal to, and it's going to be negative 7. I haven't got much space here, so I'm just going to try and split the middle here, decide what the numbers are. So we want two numbers that multiply together to give me negative 60 and add together to give me negative 7. So I believe those are going to be negative 12 and 5. Let me just write them over here. Okay, so those are going to be the two numbers that I want. Okay, right, so when I split the middle over here, I'm going to rewrite this equation as 4x squared take away 12x plus 5x take away 15. Okay, so let's factorise this part over here first. So I have to just come over here. So that's going to be, a common factor is going to be 4x. So I'll take 4x outside of my brackets. In my brackets, I'm going to have x, and that's going to be take away 3. And then I've got this one over here. The common factor is going to be 5. So we've got plus 5. And inside my brackets, I'm going to have x take away 3. Okay, so we've got the x take away 3 that's common in both, so I can rewrite this as 4x plus 5 times x take away 3, and that there would be my answer. Okay, question 17, we want to write this 10x squared take away 10x plus 4 in this form over here, so essentially we're completing the square here. Okay, so I know that I need to start by halving that number, so that's going to give me 5, so I've got x take away 5 squared, and if I expanded this out I get x squared take away 10x plus 25. I don't want the plus 25, so I'm going to take away that 25, and now I just need to add on that 4. Okay, and that gives me x take away 5 squared take away 25, add 4, just gives me take away 21. So you can leave your answer like that. Sometimes you're specifically asked to give the value of p and q. So in this case, p would have a value of negative 5 and q would have a value of negative 21. Question 18, we are factorising this expression here. So the first thing I want to do is to see if there's a common factor across all of the terms. I can see that there isn't. So I'm going to block this into two separate parts. So I'm going to factorise this part and this part over here separately. So this part over here, I can see that m is a common factor, so I'm going to rewrite this part as m times n plus 3. And then over here, this one, I can see that 2 is a common factor, so we're going to have plus 2 times n plus 3. Okay, and now I can see that m plus 3 is a common factor in both of them, so that means that I can write this as m plus 2 times n plus 3. Okay, question 19, we're asked to find the equation that is perpendicular to the line y is equal to a third x plus 5 and passes through the point 2, 8. Okay, so it's going to be perpendicular to this line. Well, this line has a gradient of a third, so the line that I want, because it's perpendicular, is going to have a gradient that's going to be the negative reciprocal of this one over here. Okay, so the negative reciprocal of a third is going to be negative 3. Okay, so now that I know that the gradient of the line that I want, I can write it as y is equal to negative 3x plus c. Okay, I'm now going to use my values of x and y on this point over here because it has to pass through this point. So I'm going to replace the y with 8 and I'm going to replace the x with 2. So that tells me that 8 is equal to negative 3 times 2 plus c. So that's going to be negative 6. So I've got 8 is equal to negative 6 plus c. And if I add 6 to both sides, that tells me that c is going to be equal to 14. So my equation is going to be y is equal to negative 3x plus c, which I now know is 14, so it's going to be plus 14. Question 20, we're writing this in completed square form. I've got 4x squared plus 32x take away 1. Now, because I have a coefficient of my x squared, what I'm going to do is I'm going to just factorize this part over here first. Okay, so that means I'm going to have 4 outside my brackets, and then I'm going to factorize this, so that's going to be x squared, and then that's going to be 8. 8x even, okay? And then we've still got this take away 1. So this expression and this expression are the same as each other. I've just factorized it so that I can complete the square on this inner part over here. So with this inner part over here now, I know that I can write this as, and it's going to be half of that, so it's going to be x plus 4 squared. Okay, so that gives me x squared plus 8x plus 16. I don't want the plus 16 part, so I'm going to subtract the 16, and then I can close those square brackets. Take away 1. Remember, the square brackets are just to make it clearer that we are doing this in separate sections. Okay, so now I can expand out the square brackets. So that gives me 4 times x plus 4 all squared. Take away, and 4 times 16 is double it again, and that gives me 64. And then I've still got this take away 1. So my final answer for this is going to be 4 times x plus 4 all squared, take away 64, take away 1 is take away 65. Okay, question 21. A graph has equation y is equal to f of x. Point A has coordinates 6, 4 and is on the graph y is equal to f of x. We want to transform that single point A to each of these different graphs. Okay, so the first one, we've got y is equal to negative 3 f of x. So we can see in this particular one, the input hasn't changed, so my x value won't have changed. Okay, so I know that I'm still going to have a 6. Okay, but the output has changed and it's become negative 3 times as big. So that 4, I now need to multiply by that negative 3, and that's going to give me negative 12. Okay, so the first one is going to be 6, negative 12. B, we've got y is equal to f of x plus 5. Again, my input hasn't changed, it stayed the same, so that's still going to be 6. But my output has changed, it's increased by 5. Okay, so I now need to add 5 to my output, so instead of 4, I'm going to have 4 add 5, which is 9. Okay, part C, we've got y is equal to f of negative 3x. So this time my output hasn't changed. Okay, it's going to stay as 4, but you can see my input has been multiplied by a negative 3. Okay, so I need to reverse that because it's my input. I need to reverse that. I need to do the inverse. So the opposite of, the inverse of multiplying by negative 3, I need to divide by negative 3. So I'm going to take that 6, I'm going to divide it by negative 3, and that's going to make it negative 2. Okay, so this one here is going to be negative 2, 4. Okay, question 22. We have a inequality here, and I can see that it's a quadratic inequality. So before I start, I'm just going to write this so I've got it in the form of ax squared plus bx plus c is less than 0 in this case. So That's going to make it x squared plus 6x take away 27 is less than 0. Okay, I'm now going to see, well, does this factorise over here? So I can see, I'm looking for two numbers that multiply together to give me negative 27 and add together to give me 6. I think that's going to be 9 and negative 3. So I'm going to write this as x plus 9 times x take away 3 is less than 0. Okay, so it's not equal to 0, it's less than 0. Okay, so I'm going to first decide what are my critical values. My critical value is going to happen when this is actually equal to 0. I'm doing this because it's going to tell me the roots to the graph that I'm going to sketch out in a second. That tells me that x is going to be equal to negative 9 or x is equal to 3. Okay, so what I now want to do is I want to draw in my graph of what this is going to look like. So I'll just do that over here. We're going to have our axes, and this just needs to be a quick sketch. We don't need to spend too much time on this. Okay, so that's my y-axis, my x-axis, so I'm going to have negative 9, which is going to be about here, and 3, which is going to be about here. And I know this is a positive x squared, so I'm going to draw a parabola that looks like this. Okay, I now want to decide what my inequality is going to actually be, and because I want, let me just label this, that's negative 9 and 3, because I want it to be less than 0, I'm looking for I'm looking for the y coordinates that are below the x-axis. Okay, so all these values are going to be less than 0, so that's going to be any values that are between the negative 9 and the 3. Okay, so I'm going to draw I'm looking for all the points in this single region over here. Okay, now I've left those open because this is a strict inequality. So I now want to describe this inequality. Okay, it's a single region, so I'm going to put an x in the middle. The lower number goes over here, 9, the higher number goes over here, which is 3, and then our kind of inequality signs are always going to point in that direction there. So it's going to look like this here, and when I read this inequality, it tells me that x is greater than negative 9, so it's greater than negative 9, and it's going to be less than 3, and it's less than 3. Okay, I write it as a single inequality because this is a single region over here. So that there would be my answer. Question 23. I'm looking to simplify this algebraic fraction over here. I've got 6x take away 12 over x squared plus 3x take away 10. There seems to be another plus sign there. Okay, x squared plus 3x take away 10. In fact, I'll write this out again. 6x take away 12 over x squared plus 3x take away 10. Okay, so I want to, first of all, I can't see any common factors across every single term here, so I'm going to look to factorise it. So let's factorise 6x take away 12, which is going to give me 6 times x take away 2. I should use my identity symbol here. Over, and if I factorise this over here, two numbers that multiply together to give me negative 10 and add together to give me 3 are going to be 5 and negative 2. So I'm going to write this as x plus 5 times x take away 2. Okay, now that I've factorised it, I can see that there are two terms here. There's a common factor of the numerator and the denominator, so I can divide them both by x take away 2. Okay, so I divide this one by x take away 2, and I'm going to divide this here by x take away 2. Okay, so that makes the numerator 6 and the denominator x plus 5. So we can have 6 over x plus 5. Okay, question 24, not quite enough room on the worksheet for me to do this question, so we're just going to do it over here. So I've got x plus 4 over x take away 5 plus x take away 5 over x plus 4. So I need my denominators to be the same as each other in order for me to add them together. So I'm now going to create a common denominator. So I'm now looking for the lowest common multiple of x take away 5 and x plus 4. Okay, so the way that I'm going to achieve that is I'm going to make the common denominator x take away 5 times x plus 4. So I'm going to rewrite this now, and we're going to have x take away 5 times x plus 4 as my common denominator, x take away 5 times x plus 4. Okay, so to make this denominator, x take away 5 times x plus 4, I need to multiply it by x plus 4. So I need to do the same thing to the numerator as well. So that's going to make my numerator x plus 4, or x plus 4 squared, or I'll write it as x plus 4 times x plus 4. Similarly over here, to make this this x plus 4 become this over here, I needed to multiply it by x take away 5, so I need to do the same thing to the numerator. So I need to multiply x take away 5 times x take away 5. Okay, and again I'm going to write it like this just because I know that in a second I'm going to have to expand it out. Okay, so I can now add them together, so I can write it as a single inequality, sorry, as a single fraction now. So that's going to make it x take away 5 times x plus 4. Okay, and I'm now going to add these two things together. So I'm going to write it down actually, just so it's clear about what I'm doing. Okay, so let's just move that up slightly. Okay, right, so now I can expand these out. So that's going to give me x times x, which is x squared. And then I've got plus 4x and plus 4x again, so that's going to be plus 8x, and then plus 16. So that's this part, and now I'm going to do the same thing over here. We've got x times x, which is x squared, take away 5x, take away 5x again, which is going to be take away 10x. Remember, I'm plussing a negative 10x here, so it's still going to be take away 10x. And then I've got the negative 5 times a negative 5, which is going to give me a positive 25, so I'm going to add 25. Okay, if we were subtracting, we'd have to be super careful here, but because we're adding, it's going to be as is. Okay, I now want to divide this, and I'm going to leave the denominator in factorized form, and it's just going to look like that. Yeah, we don't normally expand the denominator because it's already factorized and we know we can't simplify it any further. Okay, so let's check the numerator now. So we've got, put it down here, we've got x squared and x squared, which gives me 2x squared. I've got 8x, take away 10x, which gives me take away 2x. And I've got this 16, add this 25, and that's going to give me 41. So it's going to be plus 41. And then on my denominator, I've got x take away 5 times x plus 4. Okay, sometimes you want to check, well, you do want to check to see whether this numerator factorizes, because it may be that it does, and it may be that you can simplify it further, but in this particular case I don't think it simplifies, so that there would be my final answer. Okay, finally question 25. We want to solve algebraically the simultaneous equation. I've got y is equal to 4x squared, take away 9x, take away 3, and y is equal to 2x. Okay, because y is equal to this and y is equal to this over here, that tells me that I can just replace that y with the 2x, and then I've got 2x is equal to 4x squared, take away 9x, take away 3. I'm going to write it the other way around. I'm going to say that 4x squared, take away 9x, take away 3 is equal to 2x. So this is a quadratic equation, so I want it to be equal to 0, so I'm going to write it as 4x squared, take away, so I'll subtract 2x from both sides, that's going to make that 11x, take away 3 is equal to 0. Okay, so the next thing I want to do now is I want to see whether this factorizes so that I can so that I can solve for x. Now, okay, there was a problem with the video, so I'm just going to have to go through this last part again. Okay, so in order to factorize this, I needed to split the middle, so I used my AC method over here. I had -12 and -11, decided I needed a -12 and a 1, so that's how I split the middle. I then factorized it, and I ended up with 4x plus 1 times x take away 3 is equal to 0. I then decided what my values of x are going to be, so if 4x plus 1 is equal to 0, then x would have to be equal to -1/4, and if x take away 3 was equal to 0, x would have to be 3. So that's my first x value, that's my second x value. I then used this equation here to find my y values. So that's telling me y is equal to 2 times x. So to work out my y value over here, I multiplied -1/4 by 2 and got -1/2. And to work out my y value over here, I multiplied this coordinate by 3, and that gave me 6. Okay, so my two sets of values are going to be -1/4, -1/2, and 3, 6. I hope you found the video useful. Please do go back and make sure that you practice anything that you need to, anything that you're worried that you might forget. Create some flashcards. It's a great way for you to revise. Best of luck with your level 3 algebra exam. Make sure you like this video and subscribe to the channel, and I look forward to seeing you again soon. Take care. Bye bye.